My name is Carlos Cordeiro. I am an Intel fellow and also the wireless CTO of our client group at Intel. So I lead a team at Intel that is responsible for all of our, from the very conception of technologies in the early phases, where we do, some of the research on what's going to be the future of wireless technologies. In particular, in my group, we are responsible for everything that has to do with technologies that operate over license exempt or unlicensed spectrum. So that includes, Wi-Fi, Bluetooth, ultra wideband, and so on. There are many technologies that operate over unlicensed spectrum. And so my team really does the research, and then we do the standards. So we are very active in all these standards organizations that are defining those technologies. Those include IEEE, Wi-Fi Alliance, Bluetooth SIG, and many others. My group is also responsible for certification and making sure that products can work together in the field. I'm also responsible with my team on all the regulatory work that goes into spectrum that is in this area of unlicensed or shared spectrum. Yeah, so Intel, I think I think everybody knows Intel. World-changing technology, right? From manufacturing, microprocessor, process nodes, and all the leadership that Intel has. The technology that touch people's lives every single day. We build wireless products, we build CPUs. We are in the data center. We are across all the spectrum of technology. So it's a very exciting company to be with. Can you imagine using a tablet or a PC without wireless connectivity? I mean, everything that you experience today, whether it's in a phone or a PC or tablet or any of home smart speakers, it all uses wireless, and it's we spend a lot of time making sure that that wireless link works very well, because if it doesn't, then the experience that the users have with our platforms, they're not going to be good enough. So it's critical for our success on the client group, since that's what we do in my division, that we have the best wireless quality. Our CPUs can only process data that we get in and out the platform. So to the extent that that wireless link works well and provides the capacity, the latency, and the predictability that we need for the use cases that users are going to use, then we have enough workload that we can deliver the experiences that users expect. When we started Wi-Fi, the first Wi-Fi that we launched, I mean, for those that are old enough, you might remember Centrino. Centrino was a brand that Intel launched in 2003. I mean, it was all over. I mean, it was, one of the biggest successes that we had. That first product had a Wi-Fi at 11 megabits per second. You fast forward 20 years, because we launched Centrino in 2003, so we are in 2023 now. We can get speeds of 5.8 gigabits per second. So we have increased the speed by over 500 times in a span of 20 years. I was trying to think of which other technology had the same improvement in data rates in that same time span, and I could not think about anyone else. And the reason that we're able to do that, if you just think of information theory, and I don't want to get into a lot of details, but it's about bandwidth, and we've been able to make better use of bandwidth, and expanding channel sizes, and that we did that in 2006 when we launched 11N. It was what we call today Wi-Fi 4. That was the first technology that we added. We increased the channel bandwidth, and we added MIMO. MIMO was a revolutionary technology. I mean, it's amazing how the use of multiple antennas have changed the technology and have enabled the wireless systems to improve their reliability and capacity. And then over the years, as we progressed from Wi-Fi 5 to Wi-Fi 6, we started doubling the channel bandwidth, going to 160. Today, just to give an idea, Wi-Fi 7, which is the current generation of Wi-Fi, we have channels of 320 megahertz. And those operate only in the 6 gigahertz band because that's the only place that we have enough spectrum to have those channel sizes. In Wi-Fi 6, first time we actually supported OFDMA because up until Wi-Fi 5, it was all based on OFDM, single user. Wi-Fi 6, we had the capability to do OFDMA, multi-user. It's very important for, if you think of how many Wi-Fi devices you had in your house 5 years ago and how many devices you have today. We all have, Alexas and thermostats and, all sort of devices that your kids have, your parents have, everybody has, right? And there's a projection that by 2027, in just 3-4 years, the average number of Wi-Fi devices in people's homes is going to get to 25. So now you're going to have one access point that before used to serve, just your laptops, right? You have 2 or 3 laptops in your house. So now having to serve laptops, phones, IoT devices, all these thermostats and, refrigerators and IP cameras that everybody these days have in their house. That density requires the ability that you can serve multiple devices at the same time. That's the powerful aspect of FDMA. That we introduce in Wi-Fi 7, we keep going in producing Wi-Fi 6, of course, that carries over to Wi-Fi 7. And in Wi-Fi 7, we can talk more about it, but there's some very cool technology that we are doing in Wi-Fi 7 called multi-link operation that allows essentially an access point in clients to communicate to multiple bands at the same time. We call them links. The power of that is that allows you to deal better with interference. Because now imagine if you get interference on one, the client supports, say, 2.45 gigahertz, and then you get interference on 2.4, but 5 is clean, you use 5. So that gives you the ability to, to be more resilient to interference, the ability from the access point to do better load balancing because it can now distribute clients across different links, and at the same time, you're part of the same network. The ability to reduce latency, that is very important for applications because it can now, make use of whatever channel becomes available first. So we are really transforming Wi-Fi. If you think about it, Wi-Fi 6 with OFDMA, Wi-Fi 7 with MLO, and it's really exciting. And there's a lot of more stuff that that we're thinking of doing in the future. So our devices operate, in the 2.4 gigahertz and in the 5 gigahertz, and most devices do the same thing. The FCC opened up the 6 gigahertz band. So in our devices, we support operation across all these bands, and the reason that this happened, it was essentially because of the innovation that has spurred in the economical benefits that open up this spectrum, has spurred in the U.S. and across the world. There are no free spectrum today. Every spectrum, there is always somebody that is already operating. Unfortunately, that's the case today. If you look at, I'm talking really primarily about spectrum below 12, 10 gigahertz. Though that spectrum is populated with other users that have been allocated over the years by regulators. So whenever we look at how we can place unlicensed technologies, whether Wi-Fi, Bluetooth, in a given spectrum band, we need to analyze who else is operating that spectrum so that we can design the regulatory rules that would allow sharing so that we don't cause what we call harmful interference to other users of the band. I mean, just to give you an example, in the 5 gigahertz band, there are some channels that we call DFS channels. DFS stands for Dynamic Frequency Selection Channels. And the reason is that there are raters that operate in those channels. Right? And before Wi-Fi can operate on a channel, it needs to do, again, the DFS. It needs to listen to the channel and follow certain regulatory rules, how often you have to listen, and if you don't detect something, how long you can operate without doing, that select, that DFS again, And then if you move out, how long it takes for you to go back into that channel. So there are a lot of rules around that. And that was in 5 gigahertz. When we started, looking into 6 gigahertz, which is the latest and greatest spectrum for that unlicensed technologies can use, we did a lot of work to figure out how can Wi-Fi share with those users. And of course, then one natural way to think about it is that because Wi-Fi is mostly indoors, and all these services, fixed services, satellite services, they're mostly outdoors. The first question we're looking at, hey, how can we find a sharing solution whereby we can have unlicensed services operating indoors and transmitting with a given power levels that would not cause interference to servers that are outdoors. We need people that have the knowledge, for example, on radio regulation. People that have the background on who are the various users of spectrum and what is important for them, and which how can we share spectrum and understand, for example, for those users that use the spectrum, what is important for them. We need people that can actually do simulations. Can we do Monte Carlo simulations? Can we do analysis with various propagation, understanding building construction, what type of attenuation we have, what the distribution of devices, so that we can then do analysis and we can show the regulators that, well, if you assume this density of devices with this type of building deployed, for example, downtown San Francisco, which we did, by the way, in the 6 gigahertz proceeding, to then show that this is the type of power level that you can actually transmit and not cause interference. I work with people, by the way, that their main expertise is how to even write ex partes documents, how to submit documents to regulators, right? And by the way, lawyers all over, right? Lawyers, they have to be all involved in this process and sometimes reviewing what we say to regulators, how we say it. So it's really so many different skill sets to be able to effect change on a regulation, but again, not change for the sake of change for the sake of delivering a business result that can then deliver experiences to users that users expect and that benefits the society as a whole.